Right, here we are again with another example from section 5.4, doing hypothesis tests for two proportions, and I'm just using Excel here as the tool. So our question here, you wish to test the claim at a significance level of alpha equals 0.10. We have our null hypothesis that the two proportions are equal to each other, and our alternate hypothesis that p sub 1 is less than p sub 2. You obtain 89.4 successes in a sample size of n sub 1, 397. And you obtain a 94% successes in a sample size of n sub 2 equals 773. So I've got my hands in the wrong spot. P sub 1 is 0.894, and n sub 1, I left my cursor in a funny spot there, is 397. And we know we need our successes, so we'll get those here. And this times this should get us our successes here. And we're not going to really worry about the fact that it's not a whole number. So, similarly, going over here, p sub 2 is 94%. N sub 2 is 773. And then x sub 2 is this times this. So again, using the probability of success times the sample size to get those successes. And we need the successes for our pooled proportion. So that's p sub c here, our pooled probability. We add up the successes. And we divide by the sample sizes. And so here we have our sum of our successes divided by the sum of our sample sizes to figure out our pooled probability, and we'll use that to find our standard error. The standard error is the square root of our pooled proportion times 1 minus our pooled proportion. And notice I'm using a grouping symbol there. Otherwise, it gets wild. Now we do 1 over n sub 1 plus 1 over n sub 2. Close that and close the next one. And here we have our standard error. Now again, you're going to want to make sure and let Excel do all the work there. We don't want to be typing in a bunch of numbers, and so we'll just let it keep the data in the cell here. Come up with our test stat. With our test statistic, wrong here, it's going to be p sub 1 minus p sub 2. And we divide by our standard error. And now we are going to need to find our p-value. Now, distributions are normal here. Proportions are normal, excuse me. And we have a left-tailed test. So we're left-tailed. And our p-value is over here. Excuse me, our test statistic is over here. Negative 2.818 and stuff. Anyway, kind of a quick little scribble there, maybe a little rough. But since it's left-tailed, we're looking for the area to the left for our p-value. Or value, no, I don't know how you'd say that. This is a normal distribution. We have a normal standard distribution. Just click on our test statistic, and true gets us the area to the left. So, at this, and we need to make a comparison of that to alpha. Alpha, we're given here near the top of our problem, 0.10, so this is kind of like a 90% confidence level. So, entering the stuff that we have so far, our test statistic is negative 2.818, and maybe if I want to see if there's more to it, I could drag this over. 8179, so it would round that way. Our p-value 0.0024. Our p-value happens to be less than our alpha. And if our p-value is less than alpha, we're going to reject the null hypothesis. If we reject the null hypothesis, then there is enough evidence to conclude that the alternate hypothesis is true. So in this case, if we had that concluding statement, it would be there is enough evidence at the significance level of 0.10 to conclude that the proportion 1 is less than proportion 2. Just kind of putting it all in terms of this one. So here we go. Good, got it correct. It's always nice when it works out okay. I wanted to talk really quickly. I know this is the third one. It says for this test you should not use the continuity correction, and you should use the normal distribution as an approximation for the binomial distribution. So I hadn't really addressed this in the other questions. Mathematics instructors have a tendency to have a really hard time writing things that aren't always true. So there are some things in statistics that we're just kind of ignoring, like a continuity correction and things like that. To simplify this, this is an introductory statistics course. So you'll kind of see some extra sentences that are extraneous information, or really just letting us know that if we were to really dive into this, maybe or maybe this wouldn't always be true. But you can just kind of ignore that, similar to some of the things that say, hey, use StatCrunch for this or whatever. In this course, we're really looking to have you use Excel and use the methods that we're talking here, even though some of these things can be done in different ways. So just wanted to highlight that in case it's a source of confusion. And then occasionally, because this is random number generation, occasionally you'll get numbers that don't necessarily make sense. Oftentimes, if you just run with those, it will work. But if you ever have any questions about that kind of stuff, feel free to let me know. So again, you're doing a hypothesis test for two proportions. We are given our null and alternate hypothesis, so we don't really have to write those. We use that information to figure out that we have it left-tailed. I like to work through to figure out the test statistic before I draw the picture. In this case, we were giving our proportions and our sample sizes, so we had to use those to figure out our number of successes, sum up the successes, divide by the sum of the samples sizes to get our pooled probability. Using the pooled probability and the information for our successes, our trial sizes. Here, getting our standard error, taking the difference of our proportions and dividing by our standard error, get us our test statistic. Then we can draw a picture. Again, we're left-tailed here, so it's just left of this. Finding out our p-value, making a comparison to alpha, and then we made a decision here, and we should have a conclusion also. So, anyway, thanks for watching. Let me know if you have any questions.